Hello everyone. Today we're going to talk about exponents some more. Today we're in lesson 9.3 and our outcome will be evaluating powers with positive, negative, and zero as exponents. Please take a minute to write down your outcome for the day. What do you think about negative exponents or zero as an exponent? We've dealt with all positives as exponents. In the last lesson, we multiplied and divided with exponents. But what happens if the end result of that multiplication or that division is zero or a negative exponent? For instance, 5 to the 6th power times 5 to the negative 6th power is the same as saying 6 plus negative 6. Remember, we keep the base and we add the exponents. We end up with 5 to the 0 power. What do you think that is? 5 to the 0 power. And this one, 3 to the 2nd power divided by 3 to the 5th power. You should remember that you keep the base and you subtract the exponents. 2 minus 5, and what do you get? 3 to the negative 3rd power. What do you think that could be? Well, that's what we're about to find out. Consider these exponential expressions. 2 to the 4th power, 2 to the 3rd power, 2 to the 2nd, 2 to the 1st. There's that 0. And then we delve into negative exponents. Take a minute and figure out what is 2 to the 4th power, 2 to the 3rd power, 2 to the 2nd, and 2 to the 1st power. Well, I hope you came up with 2 to the 4th power is 16. Whoops, I'm writing it again. Sorry about that. It's 16, 1, 6. It's the same as saying 2 times 2 times 2 times 2. Sorry, my writing on here is a little bit shaky. 2 to the 3rd power, I hope you came up with 8. 2 to the 2nd power, obviously you know that, 4. 2 to the 1st power, 2. That's just like most of the time you see it just written as 2. We don't usually see it as 2 to the 1st power. Any number to the 1st power is just that number by itself. So what do you think our 2 to the 0 power is going to be? Well, what's happened here? 16 down to 8. We divided by 2. Oh, that's our base. 8 divided by 4. Another division by 2. That's our base. 4 divided by 2. 4 divided by 2 gives us 2. So what do you think 2 to the 0 power is going to represent? 2 divided by 2? 1. And then, since we divided by 2 to get these, we have to continue. Well, what's 1 divided by 2? 1 over 2. 1/2. How do those two relate? Think about that. 2 to the negative 2nd power. What is half divided by half? A half divided by 2, I'm sorry. 1/4. Think about cooking. When you cut a half of a cup of flour in half, or divide it by 2, you have a quarter. So then what do you think is going to be our 2 to the negative 3rd power evaluation? I hope you said 1/8. Alright, let's try some other ones. 3 to the 3rd power is the same as 3 times 3 times 3, which equals 27. That's a 27. That's really bad. Sorry. Bear with me. Not much better. It's hard to type with a mouse. 3 to the 2nd power, 3 squared is 9. 3 to the 1st power, anything to the 1st power is itself. 3 to the 0 power, that's that division by 3. 27 divided by 9, 27 down to 9 is a division by 3. 9 down to 3 is a division by 3. Notice that's our base. So 3 divided by 3, 1 again. And then 3 to the negative 1st power, what is 1 divided into thirds? 1/3. What do you think? 1/9, and then 1/27. Now I want to point something out that I didn't point out on the last set that we just did with the 2's. These 1/3 is the same as saying 1 to the 3 to the first power. Notice that I crossed the line here and I changed the sign. I put it in fraction format. I call it cross the line and change the sign. I put it in fraction format and I took the negative sign away. This works both ways in reverse, and you'll see that in a couple of lessons later. But this is the same as saying 1 times 3 to the second power. These are equal terms, equal expressions. 1 times 3 to the third power. Okay? So, what's the relationship between each pair of values? Think about that for a minute. Three to the third power equals 27. 3 to the negative third power is 1/3 to the third power, or 1/27. So I think you get the idea that when you have a negative exponent, we cross the line, we turn it into a fraction, and we change the sign of that exponent to positive, and then we can evaluate it or simplify it as it should be. So then what was the value of 3 to the 0 power? What significance did that hold in both parts? Go back and look. It's 3 to the 0. There's 2 to the 0. What are you seeing happening there? What's that pattern? I hope you said that anything to the 0 power equals 1. Anything to the 0 power equals 1, except 0. Except 0. We do have that one exception. 0 is, anything times 0, you all know that. You're smart kids. Okay, so there are two methods to understanding 0 as an exponent. Method 1 is division. 5 to the 4th power divided by 5 to the 4th power, and lands you with 5 to the 4 minus 4, which lands you with 5 to the 0. If you can remember that rule, that's a good method to choose. Or 5 to the 4th power divided by 5 to the 4th power. It's the same as 5 divided by 5, 5 times 5 times 5 times 5, divided by 5 times 5 times 5 times 5. We can take a pen or pencil and cancel these out, and they become 1. They become 1. So any number to the 0 power is 1 simplified. Okay, so I hope you have a better understanding of 0 powers. Since 5 to the 4th divided by 5 to the 4th cannot have two values, we can conclude that 5 to the 0 power equals 1. Any number to the 0 power equals 1. So now we're going to talk about negative exponents. Negative exponents occur when we are subtracting a higher number from a lower number. A lower number from a higher number, or if we're multiplying by negatives, we end up with negatives. So 8 to the 2nd power divided by 8 to the 5th power is the same as 8 to the 2nd minus 5. And we get 8 to the negative 3. Well, we have to do something with that negative exponent. We talked about negative exponents just a minute ago. Here's your other method, and let's see if this helps. Again, 8 squared is 8 times 8. Sorry, my multiplication symbol's not in there. That's a typo. Put that in real quick. There we go. And then 8 to the 5th power. Okay, so if I were to take my pen again, and I cancel a few out, there we go. I'm still left with nothing in the numerator. That's 1 left. And then 8 to the 3rd power is in my denominator. 1/8 to the 3rd. Compare these two. Take a look at them. I'm going to highlight. Take a look at this. Take a look at this. Examine that relationship. What's happening there? What's happening with these two? Since 8 to the second power over 8 to the fifth power can't have two different values, it can't have two values, we must conclude that 8 to the negative 3 is the same as 1 over 8 to the positive 3. And then we could simplify it by finding out what that is. What happens if there are variables in your expression? Look at this. What happens if we end up with this? We separate the terms. That's the easiest way to do this, is separate the terms. So we're going to write it out as if the terms were separate. B to the negative third times, don't forget, when you put two variables together, it means times, C to the second over D to the negative fifth. Whoops, that's my D to the negative fifth. Okay. We talked about crossing the line, changing the sign. Well, I told you a little bit ago it works both ways. So you need to take this D into your numerator and this B into your denominator. Because they're not alike bases, you can't just subtract the exponents here. B is different from D. Take a look at C real quick. C has no negative exponent, so it's going to stay right where it is. It's not moving at all. If you would like, if it helps you, you put a 1 in front of any of these terms, because 1 is automatically there, then you can see that it's going to go up to the numerator and it's going to end up being 1d to the fifth power, cross the line and change the sign, times c to the second, because c, remember we said positive exponent's not going anywhere, and b is going into the denominator, and it's 1b to the third power. Okay? If you have any questions, I hope that is clear. If not, bring your questions tomorrow. You should be taking these notes. Here's a toughie. Who's right? Jalen and Emily are simplifying negative 4x to the third divided by x to the fifth. Who's correct? Here's a look at their work. Take a minute, push pause, and see what you think. Okay, welcome back. Jalen looks like he subtracted. Those two bases are the same, so he kept his negative 4 where it was, because that's not a base. And he's got x to the third minus 5. Okay, wrote it a little big there, but he's got negative 4x to the negative second. And negative 4 over x to the second, because it was a negative denominator with that x. Yet last lesson you learned that the exponent only attaches to what it's only is squaring or raising what it's attached to. So that x to the second goes in the denominator. So he looks like he did okay. Let's check and see what Emily did. Here we go. Negative 4, x to the third. She's got that 3 minus 5 there, but why did she take her 4 into the denominator? A negative number is very different from a negative exponent or a positive or a number that's raised to a negative exponent. She crossed the line with that negative 4, and there it went wrong from up there. Wow! And since x squared had to go into the negative x into the bottom, she left nothing up in the top. So you have to put a 1. Something has to go there. You can't have 0 there. So 1. She had that little 1. X right there, left the 1. So Jalen was correct. Emily moved the 4. A negative number is very different from a negative exponent. Negative numbers stay. Negative exponents do not. Okay? Any questions? See me tomorrow. Write them down, please.